Let's take a look at sort of a tricky problem for a projectile motion thing. Now, I don't have a lot of information here, but I have enough to solve it, but we have to be very, very careful with what we do. It says an archer aims at a target 75 meters away. He shoots the arrow up at an angle of 35 degrees. If the target is 1 meter below the point of release, how fast should the arrow be shot? Okay, now this is tricky because I wasn't given an initial velocity. All I know is a range, a change in position in the y direction, and an angle. So let me actually go ahead and start with a picture. Okay, so over here I have my archer, and he's going to shoot an arrow this way at some speed v, and it has an initial velocity of a direction 35 degrees above horizontal. Okay, and whatever distance this is, we'll call this y meters, it comes over here and it hits a target, and this target is y minus 1 meters off the ground because it says it's 1 meter lower. Okay, so let's go ahead and see what I know. I know a change in position in y. Change in position in y is negative 1 meters. Okay, I know the acceleration in y is the acceleration due to gravity, negative 9.8 meters per second That's pretty much all I know in y. I do know one other thing, I guess. I could say v naught in y is equal to v, whatever it is, times the sine of 35 degrees, since it is the opposite of that triangle, opposite side of the triangle. Now, that's not enough information to get me either v or t, because if I use my equation, delta y equals 1/2 at squared plus v naught t, what I end up with is negative 1 equals negative 4.9 t squared plus v sine 35 times t. I have t as an unknown and I have v as an unknown. So I have two unknowns, which means I need another equation. So I'm going to go ahead and I'm going to move into the x direction. Now I do know that the distance from my archer here to the target here is 75 meters. So I know my change in x is 75 meters. I know the acceleration in x is 0 because there's no forces acting on it in the air except gravity, and it pulls down. The initial velocity in x I know is v, whatever it was, times the cosine of 35 degrees, since it's the adjacent side of that triangle. So I can say delta x equals 1/2 at squared plus v naught t, except this is 0, so I have 75 equals v naught, which is v cosine 35 times t. And so now I have another unknown, something else, or another equation with two unknowns. But I can solve one equation for the other and then substitute it in. So I'm going to pick. I'm going to either solve this one for v or for t, and t's in more places over here, so I'm going to go ahead and I'm going to solve for v. So I have 75 equals v cosine 35 times t, so I'm going to divide this by the cosine of 35, and this leaves me with vt, and so I'm also going to divide it by t, times 1 over t, and so I have 75 over t times the cosine of 35 is equal to v. Okay? So I have this relationship that I can now go ahead and sub over here into this equation. So I have negative 1 equals negative 4.9 t squared plus v, which I just said is 75, over t times the cosine of 35, okay, that's the v part, times the sine of 35 times t. Well, happily, what we see is this t right here cancels this t right here, and so I have negative 1 equals negative 4.9 t squared plus 75 times the sine of 35 over the cosine of 35, which is really just tangent 35. Okay? Well, now I have a number. The tangent of 35 times 75, tangent 35 times 75, is just 52.52. So I can go ahead and make that substitution. Negative 1 equals negative 4.9 t squared plus 52.52 0.52. Now I'm going to add over this 1 plus 1 plus 1, and I'm going to add the 4.9 to both sides as well, 4.9 t squared plus 4.9 t squared. So I have 4.9 t squared equals 53.52. I can divide both sides by 4.9, and I get t squared equals 10.92. And so t, if we take the square root of that, is just 3.3. T equals 3.3 seconds. So we know it takes 3.3 seconds for the arrow to get from where it started all the way over here to where it ended. Which means if I take and I substitute that t into this equation, 75 divided by t times cosine 35 equals v, I can figure out how fast the arrow is going when it started. So t is 3.3 times the cosine of 35 is 2.7, so 75 divided by 2.7 is 27.7. So v is 27.7 meters per second. If it's hit with, or if the arrow shot with that speed, then it will hit the target 75 meters away, 1 meter below where it's released. So this was a little bit tricky because we did have to go into multiple dimensions and do some substitutions, but you're able to do it as long as you keep track of which forces act in which direction and which velocities are